Hello guys, in this video we will be solving uh, question number 2157C maximum array 2. This question was in CodeForces round 1066, and yes, here we go. Let's read the question. You are given three positive integers n, k and q. You are also given q tuples c, l, r, which c in the range 1 to 2 and L and R are in the range 1 to n. An array a1, a2, an is maximum if ai is in the given range for each I belonging to 1 to n, and for each given tuple c lr. If c is equals to 1, then minimum of al to ar should be k. Okay, and if c is equals to 2, then the mex of AL to AR should be K. Okay. Note that the parameter K is the same for all the conditions. Find maximum. Okay. Find maximum. The input is guaranteed in such a way that a valid array always exists. Okay. This line is pretty important. Uh, there's no condition or there's no array or there's no impossible condition in the test case. This is very important and you will understand later on why. If there are multiple possible arrays, you can print any one of them. Okay. If you don't know the meaning of MEX is minimum excluded. The MEX of a collection of integers a1, a2, ak is defined as the smallest non-negative integer which does not occur in the collection A. Let's say I have a set of numbers, let's say 2 3 1 1 1 1 0. Then what is the minimum non-negative integer which is not in this list? And it is 4. Why? Because 0 is in the list, 1 is in the list, 2 is in the list, and 3 is in the list. And as you can see that 4 is not on the list, and here max of all these numbers will be 4. Yeah. Let's understand what the input is like. First of all, we will be having the number of test cases. Then we will have nkq for each and every test case. And yes, then it is followed by q lines. And each of these q lines will have three integers c, l, and r. Okay. And in the output, we have to simply print the answer or the maximum array. One thing which I would like to highlight is that let's just focus on the condition where c is equals to 2. Let's say l plus 1, l plus 2, r. Yeah, this is the condition. And one thing which I would like to say is that uh, in this bunch of integers, if c is equals to 2, then we do know definitely that each and every integer from 0 to k minus 1 will be present, isn't it? Now you may ask why? Because we are given that for c equals to 2 and given l comma r respectively, the MEX of these bunch of integers or the MEX of the integers in this range should be k. So in order to have this MEX equal to k, we should have each and every integer lying in the range 0 to k minus 1 in this range, isn't it? Now, one thing which I would like to ask you is that can let's say let's call this condition 1. Not condition 1. It may arise some confusion. Uh, let's say there are two ranges. Okay, this is one range, and this is yet another range. And for this range, c is equals to 1, and for this range, c is equals to 2. Now, one thing which I would like to ask is that here the minimum element, the minimum for c equals to 1, let's say this is L1 R1, let's say this is L2 R2. Now, as you can see, L2 is smaller than R1. So, and C is equals to 1 for L1 R1 and C is equals to 2 for L2 R2. Hence, you can see that there's this overlap between these two intervals. Now, one thing which we have been given is that for L1 for the bunch of integers in the range L1 and L1 to R1, the minimum element should be k, isn't it? Okay, but can we place k in this overlapping interval? And the answer is no. Why? Because if we place k in this overlapping interval, then the MEX of the range L2 to R2 will never be k, isn't it? But we cannot place an integer which is smaller than k as well in this overlapping interval. Why? Because then the minimum of L2 and L1 to R1 will be, smaller than k, and it shouldn't be the condition as given in the test case. So, for the sake of simplicity, uh, yeah, the thing is, we can place any integer which is greater than k. But just for the sake of simplicity, I would say that in this overlapping condition, we will always place k plus 1. Now you may ask why? Again, I would like to iterate. K plus 1 ensures that the minimum of C1 condition isn't violated, because we will place uh, k in the remaining portion of the interval, and we are not also violating the condition for the range L2 to R2, because um, we will ensure that the MEX or the integers from 0 to k minus 1 will definitely lie in the remaining portion. By in the remaining portion, I mean this portion. Now, I would like to ask, uh, you may think that how can I be so sure that there will be, how can I be so sure that, let's say, you may ask that, let's say for a condition where this is L1 comma R1 and this is L2 comma R2. One thing which you would notice is that for such tuples, or for such, what can I say, for such condition, it's impossible to build an array. Why? Because let's say this is L1 R1, this is L2 R2, and here the condition is 1, here the condition is 2. Now we have to place at least once k in this interval, and we don't have to place k whatsoever in this interval L2 to R2. So we can safely say that there won't be any condition, or there won't be any query where uh, this condition the c equal to 1 will be as like a subset, or will have starting point and ending point smaller than and greater than respectively to the starting point and ending point of the condition or the query where c is equals to 2, isn't it? Okay, now you may think that, yeah, but there will be overlapping condition, or there will be overlapping queries, and it is true. But one thing which I can say for sure is that the overlapping will be only at the ending points. It is impossible to have a small query over here, and it will segment our query or segment our interval into let's say 1, 2, 3, 4 parts. It's just impossible. The maximum segments which can be formed are 1, 2, and 3 in the absence of this condition. So I can say safely that I have a portion to work upon. I have a set of indices, And yeah, that's it. And one thing which I can say for sure is that, let's say this is L dash, let's say this is R dash. What do I mean by L dash and R dash? The range L dash and R dash will has the duty, or has to satisfy the condition for C is equals to 2. Hence, I can safely say that this is the range where 0 to k minus 1 should be present whatsoever. Why? Because in this overlapping intervals, we are going to place k plus 1, and in this overlapping condition as well, we are going to place k plus 1 here as well. So for satisfying the condition of mex equal to k, I have to place in this non-overlapping region all the integers from 0 to k minus 1. The one thing which we would like to believe is that, okay, we will find this L dash and R dash respectively, and then we'll simply place 0, 1, 2, dot, 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 k minus 1. And if this interval has length greater than k minus 1, then we can simply place any of the integers except k, obviously, in this remaining region. Now, in hindsight, it may feel that this is the correct solution, but it is not. Now, I would like to introduce you to the overlap between two queries which have C equal to 2. Okay, let's say we have two intervals. No, I would say three intervals. Let's say this is one interval. For this interval, C is equals to 1. For these two intervals, C is equal to 2. Now, and yes, you may ask me that how are you so sure that this range of L dash to R dash will have at least length equal to k minus 1? Again, this comes from the sentence that the input is generated in such a way that a valid array always exists. So I can safely say that for this L dash and R dash, now what do I mean by L dash and R dash? I would like to revisit. The meaning of L dash and R dash is the non-overlapping region. What do I mean by non-overlapping region? In this region, there's no C equals to 1 condition to be satisfied. So this is the safe region, or this is the only region where we have to place all the integers from 0 to k minus 1. But there can be a condition where, yeah, two queries with C is equals to 2 are overlapping. Now you may feel, yeah, what we can do is we will place 0, 1, 2, dot, 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 k minus 1. Now, one thing which I would like to highlight is that by this approach, you may see that you have to place 0 over here, but you have to place something which is greater than 0. Let's say k minus 1. Okay, let me take an example and which will make it clear. Let's say I have this array 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the indices, and let's say this region has C is equals to 1, and let's say the k is equals to let's say k is equals to 3. And obviously, okay, first of all I would like to say 0, 1, 2. Okay, let's say from 2 to 6 we have C is equals to 2, and 0, 1, 2. Let me, yeah, and for this, for the range 6 to 8, we will have C is equals to 2 as well. Now, what was the protocol? First of all, in the overlapping region for c is equals to 1 and c is equals to 2, we will assign the value of k plus 1, 4, and 4. This can be anything which is greater than k, which is greater than 3. Just for the sake of simplicity, we are assigning the values 4 or k plus 1 to both of these indices. And as there are no overlapping regions in for 0 is equals for indices 0 and 1, we can simply place k equal to 3. As you can see, from 0 to 3, the minimum element is k, which is 3 itself. Now we have to somehow assign some values to all of these remaining indices. Now, one thing which you may ask is, what about the indices 9 to 12? They have no conditions, so you can place literally anything. You may place 0, 0, 0, and it won't matter. Yeah, we don't have to worry about the values in this range. Now, one naive approach which we were thinking of was that we will assign 0 to k minus 1. We'll start from 0, then we'll 1, then 2. As you can see, if we do the same for 6 to 8, we will again assign 0, 1, 2. But is this possible? And the answer is no, because we can't assign two values for a single index, hasn't it? You may fail, then what should be the condition? First of all, I would like to explain why is this a problem in itself. Okay, so the usable region for this interval is 4 to 6, and the usable region for this interval 6 to 8 is 6 to 8 itself, because it doesn't have any of the overlapping condition with the query c is equals to 1, isn't it? But this usable region is of size 3, and the usable region for this q equal to 3, let's query 3, is 3 as well. Now you may ask, why is this a problem? Because you have to somehow assign a value. Let's say I assign the value 0 here. Then I can safely assign 0, 1, 2 to the remaining indices, and I can be happy. Why? Because now 4 to 6 in this region, all the numbers from 0 to k minus 1 lie. Yeah, all the numbers are present. And in this region from 6 to 8, all the numbers in the range 0 to k minus 1 are present. We ask, how do we recognize this? As in, how do I take care of the values? Let's say there were three intervals. Let's say this was one interval. Let's say this was yet another interval. And let's say this was an interval in itself. And all of these have c is equals to 2. Now, if you try to mechanically, come up with some sort of logic in order to satisfy all these three queries simultaneously, it's pretty difficult. If you think, oh, if there is, we will try to, we'll try to find these overlapping conditions and assign some values, and we use a hash set or something to determine the remaining values or the remaining non-present values or the absent values, and then we will assign those values accordingly. But the thing is, the implementation is very difficult. But I would like to ask you a simple question. This will make things a lot clearer. The only question or the only hard part or the bottleneck of this question is understanding how do we handle the queries which are indeed overlapping. Let's say there are multiple overlapping queries and all of these queries have c is equals to 2. This is a big problem. Now whenever you are, whenever you think of numbers, let's say lying in the range from 0 to k minus 1, then I can for sure say that if I take a modulo of any number, then it will lie in the range 0 to k minus 1. Now the thing is, we have to somehow determine, what can I say? We have to somehow determine, we have to somehow assign a single value to this overlapping indices. Let's say the index 6 lies in in the query 2 and in the query 3 as well. If I assign somehow a common integer and I have a knowledge that the integers 1 and 2 are missing for query equal to 2 and query equal to 3 respectively, then I will assign the remaining integers accordingly. Keeping this in mind, let's say I have the safe region. What do I mean by safe region? I hope you get it. Let's say I have a bunch of integers. Let's say 2, 3, not a bunch of integers. Let's say these are the indices, 6. Now let's say if I assign this is a safe region, and let's say k is equals to 4. Now what's 2 modulo 4? It's 2. What's 3 modulo 4? 3. 0, 5 modulo 4, 1. 6 modulo 4, 2. Now, one thing which I would like to ask is if there are key consecutive integers, then I can for sure say that if we take the modulo of all these integers, then all the numbers lying in the range 0 to k minus 1 will be present. I hope you guys are getting me. Okay, let's say let's say k is equals to 1, 1, 2, and I have, let's say 103, 104, dot dot dot, till let's say 103 plus 112 is 215. Yeah. Okay, and the remainder of this is 103. Now as I add 1 to this 103, because indices are contiguous numbers, now the remainder will be plus 1, 104, 105, dot dot dot, until 111, and after adding 1 we will have 0 again, and we'll continue this journey. So okay, let me make things a bit more clear. Let's say let's say this is number line. Forget about all of this. Let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say let's say here k is equals to, let's say 3. So 0 modulo 3 is 0, 1, 2, 3 modulo 3 is 0, 1, 2, 6 modulo 3 is 0, here 1, 2. Let's say if I take k is equals to 4. 0 modulo 4 is 0, then 1, 2, 3, 4 modulo 4 is 0, 1, 2, 3, and so on. So let's say I take any of this, any number. Let's say if I take any x in this number line, let's say I take x is equals to 3, and let's say I take x plus, let's say what's the value of k? Let's say it is 6. So I can take x plus k, and which is equals to x plus 3, which is 6. And as you can see in this range, I have all the numbers lying in the range 0 to k minus 1, which is 0 to 2. So I can for sure say that if I have a bunch of contiguous integers, and the number of these integers, or the length of this bunch, or the length of the given interval, I hope you're connecting the dots, is at least equal to k, then I can for sure say that if I take modulo of all these values, then all the numbers lying in the interval 0 to k minus 1 will be present. Why? Because as you can see, if we take modulo, then we are actually forming a cycle. If we take modulo of contiguous integers, then we are actually forming a cycle. And to complete a cycle, let's say I have a number 5, and the k of 5 modulo k is actually 2. Now which will be the next number which will have the same module, or which will have a modulo equal to 2? And I can simply say, in order to complete this cycle, the next number should be 5 plus k. Now what is 5 plus k? It is 5 plus 3 is equals to 8, and I can simply say that 8 modulo 3 is indeed again 2. Why? Because we will be again at the starting point. So if I say that, if I assign, uh, let's say this is c equals to 1, this is yet another interval, c is equals to 2, this is yet another interval, c is equals to, let's say, 1 again, and this is another interval, c is equals to 3. As you can see, these are the safe zones. Now if I say that if in these safe zones, now what do I mean by safe zones? Safe zones are the indices where c is equals to 1, c is equals to 2 itself. Okay, are you getting me? So let me try to standardize my solution. Let's say this is a region where c is equals to 1 and c is equals to 2, both are present, both conditions are present, and in this range we will assign the values k plus 1. In the for the index where c is equals to 1 only, then I can simply assign the value of k over here. Of now if there's an index which doesn't have any query, which doesn't have c is equals to 1 or 2, then I can simply assign any value, or I can just any arbitrary value. We can select any arbitrary value, let's say 0, and it will be of no issue. But the only indices which we are which we should think of are which have c is equals to 2 only. Then what am I proposing is that for all of these indices which only have c is equals to 2, we can simply assign the ind modulo k value to the respective ind. Now you may ask, why? How is this valid? As I have proved earlier that the length of this interval will be greater than equal to k. But you may ask, what about Vaibhav? What about the interval where what about the overlapping intervals for just a second, I have made a mistake over here. Yeah, what about this interval where two or multiple c is equals to 2 queries are overlapping? And my answer will be, just don't worry about these intervals. Now you may ask, why? Because okay, first of all, this is invalid. Yeah, first of all, this won't exist. Why? Because I have stated earlier that uh, query with c is equals to 1 can't be a subsegment of a query which have c is equals to 2. Yeah. Now you may wonder, Vaibhav, how can you be so sure that all of these numbers in the safe region of another query will be satisfied? And my answer is, only the safe regions overlap. And let's say if now what do I mean by overlapping conditions? Overlapping condition is where let's say ind is equal, where for each and every ind in a given range, let's say L dash to R dash, we have C is equals to 2, but for different queries. But we were trying to finding where we were trying to find out a technique where we will assign the this common range, some common value, and then we have to memorize somehow the remaining values. But this cycle will continue for its own query, and this cycle will continue. Let's say it had k minus 2, k minus 1, dot 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 0 1 k. Are you getting me, guys? Basically, you don't have to worry about the overlapping conditions. Are you getting me what I'm saying? Let me reiterate it. Basically, if two queries with c is equals to 2 are overlapping, then what do I mean by that? Basically, these are the indices which are two queries, and both of these queries have two or multiple queries which have c is equals to 2. Now, these are actually the safe regions. These overlapping regions are the safe regions. Let's say um, um, I assign a value k minus 2, then I can for sure say that as it is a safe region, I can for sure say that it will be a part of a segment or part of a contagious, indices which have, which have the length greater than equal to k. Then do I have to actually worry about the remaining indices? No, they will take care of itself. They will take care of themselves by assigning themselves ind modulo k. I hope that you have understood what I'm trying to explain. Basically, this was my attempt trying to, justify why ind modulo k is valid. If you guys have any other doubt, please comment. I know this is kind of, a bit difficult to understand why this would work out. If you have any doubt, please, comment, and we'll just check the implementation. We are taking input t, we are taking input nkq, then we are, creating an array of size n plus 1 because there's one best indexing. Then what are we doing? Basically, yeah, basically what are we doing? Basically, okay. Uh, First of all, we are iterating for each and every through each and every interval, and if the given interval or if the given index has only constraints dot I equal to first, yeah, I hope you guys are getting me. If it basically I have just implemented where if a certain index has c is equals to 1 only or 2 only, and yeah, you get it, guys. So basically this is the implementation. Let's say condition of I represents the condition. Let's say if condition of I is equals to 0, then there's no condition, and we can simply assign any value. You can assign k plus 1 0 anything. If the condition of I, or what do I mean by condition of I? Basically it means that uh, um, there's at least a single query which has c is equals to 1. Then as discussed earlier, we should assign value k for this condition. Now what do I mean by conditions of I equal to 3? This is a condition where um, two queries which have c is equals to 1 and c is equals to 2 are overlapping. And as we had discussed earlier, any value which is greater than k can be assigned to such indices. But I'm just assigning arbitrary value of k plus 1. And as stated earlier, in the safe region, what do I mean by safe region? The indices which have c is equals to 2 only, we will just simply assign the values I modulo k and then print the array. That's it. if you're kind of confused in the implementation of conditions why, let's just go through it once. It's pretty simple implementation. mm, yeah. Sorry, let's say this is array. Yeah, and let's just submit our solution. Oh, what is going on? Okay, I guess for some reason I cannot. Okay, yeah, okay, submit. Okay, I'll just submit from here. Okay, CF practice 20. And the question number is 2157C. Yeah, we are over here. Let's just submit this file and hope we get an AC. I agree that, my explanation wasn't, polished, but this is my attempt. If you go through the tutorial, even the editor, or what can we say? Just a second. Yeah, and let's go through the tutorial. This is question C. Even if you go through the solution, bonus in the above solution, we assign I mod k to the ith element only covered by MEX constraints. However, assigning I mod k to such elements where I also works. Now, can you prove it? Okay, so this was my attempt trying to prove it. The rest of it is pretty easy to understand, but this is my attempt trying to explain to you, trying to explain how the cycles work in modulo, and how we don't have to simply care about this overlapping situation, because uh, if a certain constraint where c is equals to 2, for each mx constraint there's at least a safe region which has length greater than equal to k, and if they overlap, so be it, we don't have to actually worry about them. And so this is my attempt trying to prove, and I hope you understood. If you haven't, please comment, and I would like to improve. Thank you.